All right, let's just jump right into this. Welcome to today's Explainer. We are going to unpack something so unbelievably massive, so absolutely fundamental to our daily existence that we completely take it for granted, mostly just because we can't see it. We're talking about Earth's invisible shield, our magnetic field. We're going to explore exactly what this shield is doing for us right now, and more importantly, dive into some pretty wild new data showing that this very shield is actually mutating right above our heads.
To really wrap our heads around what this shield does, I want you to picture our beautiful blue marble exactly as it is today. You've got your morning coffee, the birds are doing their thing, everything's perfectly normal. But suddenly, there's absolutely zero trace of geomagnetism. The shield just entirely vanishes. What would happen? Well, let me just tell you right off the bat, it wouldn't exactly be a great day for planet Earth.
Section 1. A world without magnetism. The catastrophic consequences of losing our shield. So let's look at the bizarre and frankly totally apocalyptic things that would start unfolding if this crazy hypothetical actually happened. The biological world, it would descend into absolute chaos in a heartbeat. We always think of compasses pointing north, right? But without a global magnetic field, a compass is really just a tiny magnet desperately looking for a friend. It would just point to whatever random magnetic rock happened to be nearby. Actually, there's a place right now in the Central African Republic where natural magnetic anomalies already cause compasses to go totally haywire. But it is way more than just our human navigation tools. Animals like sea turtles, migratory birds, even tiny honeybees, they all have biological compasses built right into their bodies. They're called magnetoreceptors. Without the field, sea turtles would be completely lost in the open ocean. Birds would fly totally off course. Bees wouldn't even be able to find their hives to pollinate our crops. We'd literally be looking at an immediate, catastrophic wave of extinctions.
And this brings us to the macro-level planetary stakes, which are just mind-blowing. On one hand, you have our protected Earth. Right now, our magnetic field channels the brutal solar wind toward our poles, creating those jaw-droppingly bright auroras. Fun fact, historically, some auroras were so bright people could literally read a book by them. But contrast that with a stripped planet. Without our shield, that solar wind would just relentlessly blast our upper atmosphere. Those beautiful auroras, completely gone, replaced by these faint, dull glows, kind of like what you see on Venus or Mars. And actually, speaking of Mars, this is exactly what happened to it. Billions of years ago, Mars lost its magnetic field, and the solar wind just violently ripped its thick atmosphere and its oceans right out into space. Without our shield, our water evaporates, our air gets completely stripped away, and we'd be living on a barren rock.
But hey, let's play devil's advocate and say we somehow managed to hold on to our air for a little bit. The immediate health and tech fallout would still be absolutely terrifying. We'd be dealing with a constant, nonstop bombardment from deadly cosmic rays. You know how astronauts on lunar missions would often report seeing these weird, mysterious flashes of light when they closed their eyes? That was cosmic rays passing straight through their retinas, and it gave a lot of them cataracts years later. Down here on the surface, without that magnetosphere, the global risk of DNA damage and cancer would just skyrocket. And what about our tech? Back in 1909, a massive solar flare slammed into Earth and completely fried the power grid in Quebec for 12 straight hours. Without a magnetic field, every single day would be like the Quebec blackout. Satellites tumbling out of orbit, power grids constantly frying, a total mess.
Section 2. The South Atlantic Anomaly. The reality of our changing magnetic field. Okay, everybody, take a deep breath. That was our absolute worst-case scenario. The good news here is that our magnetic field isn't completely disappearing. But, and this is a big but, while the shield isn't vanishing, it is mutating in some massive, wildly unexpected ways as we speak. Let's start with this really insightful quote from Chris Finlay, a professor of geomagnetism. He says, "The South Atlantic anomaly is not just a single block. There's something special happening in this region that is causing the field to weaken in a more intense way." So what exactly is this anomaly? Basically, it's a huge weak spot in our magnetic field. Scientists actually first noticed it back in the 19th century, just southeast of South America. But as Professor Finlay points out, it is acting incredibly strangely right now. It's fragmenting and intensifying in ways the scientific community honestly just did not see coming.
The really crucial thing to grasp here is the sheer scale of what's happening. The South Atlantic anomaly has grown by an area almost half the size of continental Europe, and that's just since 2014. That is a staggering footprint for such a short amount of time. And guys, this isn't just some abstract curiosity for scientists in white coats. When our satellites pass through this massive expanding weak zone, they lose their protective shield against cosmic radiation. They're suddenly exposed to way higher risks of hardware damage, temporary outages, and totally random glitches. We've got this modern, multi-billion-dollar orbital infrastructure flying right through a massive, growing vulnerability.
So you might be wondering, how do we even know all this is happening? Well, the modern timeline of this discovery really kicks off in 2013. That's when the European Space Agency launched the SWARM mission, which is this constellation of 3 identical satellites custom-built to meticulously map Earth's magnetic signals. By 2014, their data confirmed the anomaly was, for sure, steadily expanding. But look at 2020. That is when things got really weird. A secondary region of rapid magnetic weakening just suddenly opened up right southwest of Africa. It essentially started splitting, kind of developing a brand new, intense core of its own. And these SWARM satellites are going to keep tracking this right through the expected solar minimum in 2030. That upcoming minimum should give us some incredibly clear, interference-free insights into what on Earth, literally, is going on here.
Section 3. Inside Earth's molten core. The hidden engine 3,000 kilometers underground. To really understand what's happening way up in the sky, we actually have to look down. Way, way down. We need to investigate the hidden engine that's driving this entire planetary drama. You see, our magnetic field isn't coming from some giant, static bar magnet buried in the dirt. It's a dynamic, almost living thing. 3,000 kilometers straight down beneath our feet is a vast, mind-bendingly hot ocean of molten, churning liquid iron filling the Earth's outer core. And as this highly conductive liquid metal violently churns and flows, it generates massive electric currents. Scientists kind of compare it to a bicycle dynamo, but obviously infinitely more chaotic. This churning underground ocean is the hidden engine constantly powering, twisting, and shaping the invisible shield wrapped around our planet.
And that churning, boiling ocean brings us to this highly specific, totally fascinating phenomenon: reverse flux patches. It sounds like sci-fi, right? The SWARM satellites actually allowed scientists to essentially peer into the boundary between that liquid core and the solid mantle sitting right above it. Normally, magnetic field lines are supposed to radiate out from the core in the southern hemisphere. But these reverse flux patches are these weird, unexpected areas where the magnetic field gets confused. It literally flows backward, sinking back down into the core instead of radiating out into space to protect us. And thanks to SWARM, scientists tracked one of these reverse flux patches actively moving westward beneath Africa right now. It's quite literally sucking the strength out of the magnetic field above it, causing that exact rapid drop we were just talking about in the South Atlantic anomaly.
Section 4. Navigating our shifting future. A global magnetic tug-of-war.
So we have this highly localized drama going on over the Atlantic and Africa. But if we zoom back out to a global view, this turbulent core isn't just messing with the South Atlantic, it's completely redrawing the magnetic map of the entire world. And this brilliantly illustrates just how insanely dynamic our Earth really is. Take Canada, for example. The field over Canada has been steadily weakening, shrinking by an area roughly the size of India. But at the exact same time, the magnetic field over Siberia has actually been intensifying and expanding by an area the size of Greenland. It's this massive planetary-scale tug-of-war. The field isn't just fading away, it's smoshing around. It's getting weaker over here, bunching up over there, all based entirely on the chaotic weather of molten iron thousands of miles deep inside the Earth.
This complex tug-of-war is actually doing something else crazy. It's dragging the northern magnetic pole rapidly away from Canada and shooting it straight towards Siberia. Andra Strom, the ESA SWARM mission manager, sums it up nicely. It's really wonderful to see the big picture of our dynamic Earth thanks to SWARM's extended time series. And she's completely right, because without these constant, ongoing satellite measurements, our entire modern navigation network, everything from the GPS you use to find a coffee shop to commercial aviation mapping, would become dangerously inaccurate as the poles drift and these massive magnetic regions completely shift their balance.
Which brings us to our final thought for today. We started this whole thing by imagining a world where our magnetic shield just vanished. And sure, we know that's not happening right now. But the reality we are facing is almost as strange. We are living on a planet whose very life support system is constantly sloshing, weakening, strengthening, and migrating right beneath our feet. So as the hidden engine in Earth's core just continues to shift, how exactly will our highly sensitive, totally technology-dependent world adapt to a constantly mutating magnetic shield? Our satellites, our power grids, our nav systems, they were all basically built for a static Earth. But as we're learning, very quickly, Earth is absolutely anything but static. Thanks so much for digging into this explainer with me today. Keep that curiosity high.